So, this is our next speaker, IoT means security. Please welcome David.
Hello everyone. So I'm presenting about IoT means security. I'm currently working for Samsung in UK. So this talk is going to cover a bit about why there is a need for security in Internet of Things devices. Then it will go into the implementation that I'm working on, IoT. Then it will just give you a brief introduction about what the security model and how security is. So we'll have, as I said, we'll have a brief introduction of IoT. Then I will briefly describe how the authentication and the device identify each other in the IoT model, followed by the provisioning step, which is about how it gets information about other devices which you have. Followed by the network security, how the encryption works, how the device to device communicates, how the packets are followed by a privacy, where it implements basically access controllers, finding out which device has the permission to access which resource. I can understand a bit more as I go on. So why do we need IoT security? Is because of the growth that is going to happen in the IoT devices. Currently already it's 1.9, but it's going to go further in 2020 to 20 million, so there's still a strong growth. But at the same time, the current devices which are currently there, they're found to have several issues. So when it was investigated, most of the devices, for example, 70% of them have cloud issue, 90% of them have only with access to other people, as well as 70% of them are unencrypted, and 80% of them have privacy issues. So this is based on the current IoT devices. So there is a strong need for devices which are secure, they can communicate securely, and they are at the same time interoperable with each other. So that's where IoT comes into picture. Briefly about why there is a need for IoT going further. And also this communication which is there in the IoT world for the local devices is mostly based on multicast communication. By sending a multicast packet. So that also implies that it's available, the packet when it's sent or not. It's available, it can be sent by anyone. So when you're trying to discover, for example, a light bulb I'm trying to discover from my mobile phone, it should also imply that it should be only available to my device if it's in my home network, not to the person living next to me. So that we need to ensure that. So that's the reason why we need authentication. Yeah, the authentication is more in terms of the device authentication, how the device authenticate each other. Authorization in terms of how the access control policies are put in place to ensure that light bulb is accessible to me. And encrypting in the sense that everything is encrypted, because we saw that the current devices still don't support that. So going into IoT, IoT is a Linux Foundation collaboration project. It intends to implement the OIC, which is an Open Interconnect Consortium. It has defined a standard for the devices to interoperate and communicate with each other. It's a consortium, I think so now, with 134 companies. So it's a reasonable companies who are trying to define how the devices can interoperate and communicate. At the same time, it has a certification where it certifies that this product can speak to another device. It also tests the security to ensure that the devices which has been provisioned and onboarded, as you will see, are the only one that communicate with each other. It's based on a RESTful interface in the sense that the light bulb will expose itself as a URI. Expose itself as a A/light, for example. And that's how it's discovered by the other device using CoAP. So just to give a brief overview about how it looks like. So you have a light bulb, here it exposes as a resource, and it has an attributes in it can have. And for each resource what it has access control policy defined for it. And on the other hand, it has a client which tries to discover this resource, and based on the permission it has, the server will respond back to it. So there is a distinction over here between the client and the server. Server is more of a constrained device where it will have a very limited functionality, while client is more of a rich device from which the communication actually happens. So how it looks like, it's divided into small and big device kind of a thing, where the light device is having only the base layer. So I'm not going to go into the details about all of the layers, but I'm just going to concentrate on the security part of the architecture, which includes the DTLS, and DTLS is Data Ground Transport Layer Security, which runs on top of CoAP. CoAP runs over UDP, so DTLS is a version of TLS that's designed to run over UDP. It also includes the SRM, which is basically a place to store securely all the credential information. So, as I said, the security is revolving around resources. So it tries to secure, for example, when you consider it in the form of a light bulb, for example, here you have to just consider trying to secure it as a resource A/light. So in terms of the software, it's going to secure it in that terms. To do that, it has 3 different steps what it follows. The first step is basically authentication, and for authentication, a step that happened before that, that's onboarding. After the device is onboarded, each device gets a particular set of keys, which is a pre-shared key or it could be a certificate, and that is used for the authentication purpose as well as to establish the secure channel as the communication happens each time. It also has access control policies in place so that you might make for example, your TV or your mobile phone both have an access to the light, but you would like to only switch on or off your light via mobile phone, not via TV. So you can set a different access policies for each device. So the basic step is onboarding and provisioning, and I'll be describing that more in detail. So before going in onboarding, I want to make clear what the device security, why we need onboarding. So the provisioning is all about provisioning is about having a different set of devices which are there in your house. Like for example, here we have a mobile phone communicating with the TV and a router, but it's not communicating with the light. So we are restricting the devices that it can communicate with, as well as it also implies that the devices that are to be communicated, you're defining which can communicate with each other. So if you have, for example, if you have a neighbor, he will not have access to the light, but we want to ensure that, and that's what it's all about device security. So why we need it? So CoAP is quite famous for making non-web vulnerabilities. So they have defined for IoT also, and they have defined 10 IoT vulnerabilities. The 5 related to a device are most devices currently have, like for example, a USB port where you can plug it and get all the debug information. So there is no hardware hardening that's implied on the current set of devices which are there. As well as in terms of the software, the interfaces, the configuration, that's not securely done. At the moment it is exposed, anybody has an access to it. As well as the firmware can be updated by anyone, so there is no proper security mechanism before the firmware is updated. So that's the reason we have defined an onboarding mechanism. Onboarding mechanism is a way to ensure that to make the device as part of your network. So you can imagine getting a light bulb in your house, and once you get the bulb in your house, you want to ensure that you get the network information what you have, like your Wi-Fi credentials which you have in your house. You want to give the details about that, but as well as you want to give it kind of a key that we will be only communicating with. So this is a very isolated communication that happens. So you can imagine the bulb not having any information, for example, about your Wi-Fi access point. So you can just have a QR code, scan it, get the details about, for example, if it has a Wi-Fi connected, it is the credential, SSID, and the password. You make an onboarding tool which could be on a mobile phone, could be on a router, and you make a one-to-one communication. This one-to-one communication is based on 3 protocols that are defined: just work, random pin, and certificate. So they are kind of lower down the security, but the onboarding process gives 2 things which are very important for this communication that happens next. So, first thing, it gives is a pre-shared key or certificate, and the second thing, it gives a device ID, which is the ID which is used for their communication, that both ends identify each other using that ID. So that are the 2 things that gives that are as a result of onboarding. So to describe a bit about how Just Work works, Just Work is not considered to be secure, but you can consider it, for example, like this light bulb that I've been using. You need, for a light bulb, you don't have a display, you can't enter any credentials, so as soon as you bring it, you have to establish some communication mechanism to give a key to the device. This is based on, everything, as I said, is based on a resource. So we are trying to check a resource, which is DOXM here, which stands for device ownership. As after checking for device ownership, basically we set the Just Work and make a DTLS communication using anonymous cipher and push the key from the onboarding tool to the device. So just to make sure that here the communication is initiated by the user. So onboarding tool has to be started by the user, it doesn't happen automatically, so there is a user interaction happening. So if you bring a device in your house, you cannot think that the hacker might attack it and make the device as part of this. But if he makes it, then the state will not, the resource state will not be the same, it will be changed. As well as you cannot make it part of your network. So this is expected that it's an isolated communication which happens only one time when you bring your device, and it's very fresh and it doesn't have any network permission information. There is another mechanism which is more comparatively secure than the Just Work, which is random pin. In random pin, both the ends basically enter some kind of a pin, which is a random pin generated on the onboarding tool, entered at both the ends, and they make use of DBKDF to generate the key, and using that key they make a DTLS connection. It's comparatively secure than Just Work, but the same onboarding tool has to be started from the user to make this happen. There is a third way of doing ownership transfer, which is asymmetric. Here it has more complex model because you need a certificate signed by some authority. The certificate has to go both in the devices, so it has to go in the onboarding tool as well as the device that you bring. So for example, light bulb needs to have that certificate in place, onboarding tool needs to have the certificate in place, signed by the same authority, and then when you bring the device in, you start it, the connection was established, the detail is which is established is using that certificate signed by the same authority. And when the connection is established, onboarding tool pushes a new certificate which is for that particular environment, signed by that onboarding tool to the device. So onboarding tool here is playing a very important role because that's where your devices become part of your network. It's not expected to be running on all the devices. It could be on a mobile phone. It could be on a router. More secure is router because if you lose your phone or something, then you lose your onboarding tool, which is your main source. So it's expected the deployment model to be more of a gateway device which has this information. But for example and for different purposes, it's currently is part of an application running on a mobile phone, which is store secure. So going more in after the onboarding is done. So onboarding, as I explained, gives you a key and a UID. So once we have that, next step is provisioning, which is a light bulb getting information about a TV. Because we have a pre-shared key that's been generated here, we need a way of getting the information about all the other devices in the house. So provisioning helps us to get that information to the, for example, to the TV, information to the light bulb so that they can make a connection between a secure connection. So what it does is, now when the onboarding tool has given you a key, you make a new DTLS connection with the provisioning server, which is a bootstrap server we call. And once we make a connection, it checks the state, what the particular state of the stat is. If it sees that it's not provisioned at the moment, it basically tries to push all the information about all the other devices which are there in the user network to the new device so that it can communicate. But at the same time, if the information is if the new device gets added to the network, it sees the commit hash value over there to decide whether it needs any update. There is a hardware hardening also specified, which is not implemented, but more of guidelines for the hardware to make sure that the secure storage and all the information are securely stored onto the device. So it specifies how the random generator should be or other details to ensure that the randomness or the secure storage is properly handled in the device. So in terms of connectivity, I have to speed up because I have 5 minutes left. So local and remote connectivity implies that there is a connection that's established between the devices in the house, as well as there is a possibility of making a communication outside. So to handle that, why we need it is because of the less encryption and, as I specified earlier, and there is a less authentication or authorization between the devices. So the secure connectivity is done using DTLS, where the IATVT stack is actually communicating with tiny DTLS library to get all the DTLS, but IATVT holds all the secure credential information inside the devices. And when they are trying to communicate with each other, both the ends verify each other using the device ID, which was generated as part of onboarding. They encrypted at both the ends to verify each other. So for remote connectivity, it makes use of an XMPP, where it's not expected that all the devices will communicate remotely. It's only expected that the gateway device, which is is the only one that communicates, and they communicated using the JIT IDs for each device. But they make use of an in-band byte stream to establish a DTLS connection between the device and. So the onboarded keys that we have are still required for a device which is outside the house also to communicate with the gateway. For example, here needs to have that key to communicate. So there is an in-band byte stream with the DTLS established internally on top of it. So apart from that, it also has a privacy where it basically just tries to imply that you can basically segregate the 2 different areas in your room, in your house, and restrict who has permission to what. So each resource has access control entries for them, which is basically who has the permission to read or write. The access control policy could be, for example, all the policies could be there on the light bulb, but you can imagine it's quite constrained, so it can have an extra server, which is access manager server, which makes sure of keeping the access policies on it. You can define it as per group, per access, per resource, so you can make it fine-grained as you want. So it will be more clear from this example. So if you, for example, want to turn the light on, you can make a permission to it, and if it sees that you have read permission, it will give you a response back to the server. But if you're trying to change the state of it, you don't have permission, just have permission to read, it will reject your permission. So you could make a connection with the device, but you can't change the state of it because of the access control policy not in place. The remote access control is exactly the same, but you just have another server where all the requests go. It could create a bottleneck, but it's also useful for a small consistent device. So to conclude, I showed you about the different advanced security issues which are there. There are some solution IATVT provides. There are still a few left. Firmware update that is not currently implemented because small device doesn't have access to the remote device directly, so it has to go via gateway, so it's not currently there. But other issues like physical security or interfaces, using combination of different techniques to try to provide a secure mechanism. Okay. So thank you. Thanks for your time.
So we're using FOSDEM for the philosopher identification to know what the provisions are for the devices. So does that mean it is also a single that gets compromised and other devices they give access to compromised devices?
So you mean to say make a connection from outside to the gateway to get to become
basically gets access to devices, and then after
we have the hardware hardening in place, so that's why we are clear that there is always mechanical, and that's very nicely having
Yes, so maybe everything else is in defeating that plan.
yeah, that's one plan. We need somewhere to store them.
More questions? Hey, so I was a bit surprised when you said you would prefer like the other products, for example, from the gateway. For me, like that's such a huge attack surface compared to sure, but I mean, like, I was surprised that you would consider that because, like, for example, that's, first of all, routers are one of the historically terrible points of security. They have, like, WAN access, so you're not only, like, being attacked by your neighbor, you're being attacked by the whole internet. So I'm just surprised that was recognized.
It's going to have a different form factors. How the deployment should work is probably, as I said, we currently have some mobile phone, that's how we are onboarding at the moment. But in deployment, it's going to be generally in the sense that it will have different kinds of access for onboarding. Onboarding, for example, is not just run on it, but it will not be part of an access, which is, for example, an access in my mobile phone, remote, we're not having access to it. Different modules.
Sure, but I'm not talking necessarily about the attacks. I'm just talking about the attack surfaces starting.
As I said, the gateway via SIM is because, for example, you have mobile phone that is using it, so that's the reason why I say it's about
More questions?
So it's based on the specification of OIC. Yeah, OIC is the connector, so the specification defines certification based on it, that's what it is actually tested. So
Hardware and software? Hardware and software?
Hardware design does not specify the hardware hardening, so it doesn't, it makes sure that the device has that policy, but it doesn't test the software.
Any more questions? I think we have some couple more minutes.
So I have a logistics question about volatility. I've tried to look at the logs and everything. I didn't find any way to just look at the development. I found a way to download the source code. I found a way to sign up for an account, possibly have the authorization to read the Git or something like that. And is there a way to have a semi-public Git or something?
It's there on GitHub. The source code is there on GitHub.
Okay, because I didn't find the link on the main page of the activity.
It's there. It's replicated on GitHub, so you can all this.
That would be great. Thanks.
Any more questions?
Thank you. Thanks for your time.
Give a warm hand to Abib. Thank you.